basically when you talk about intermolecular forces, there's three main types. Van der Waals forces / London forces. Let me add that one. London. Dipole, and hydrogen. Basically, dipole is the key of the whole thing. So let's start with dipole. Okay, so let's start with, so let's say HCl. When two HCl's are next to each other, this side is an HCl is positive, and this side is negative, this side is negative, this side is positive. So they form like a type of bond. So just imagine that these two form a bond, and that's called a dipole-dipole bond. These are pretty strong, and that's what dipole-dipole bonds are. And we'll talk about the strength of bonds in another video. Well, which ones are the strongest? Dipole-dipole, hydrogen. But there's another bond here. These are hydrogen bonds. These are just simple a type of dipole-dipole bonds. These are just a special type which they contain hydrogen. So that's pretty obvious. They contain some sort of hydrogen. So HO, HC, and HN. Sorry, not HC. It's supposed to be HF. Alright, so those are some of the types of things that could be. So why do they define hydrogen as a different type? Well, hydrogen, so when you take away an electron to hydrogen, it just becomes one positive thing. The electron's gone to the other side. So it's extremely positive, and that's why they gave it a different name, because it's extremely positive. It has it's the highest charge density. It's one of the highest charge density. H plus ion has one of the highest charge densities. Because of that, so when HF forms a bond with something else, such like with itself, let's say, H, and this is positive, so negative, negative, positive. When it forms a bond, it's called a hydrogen bond. So how do you know? Let's identify some types of hydrogen bonds and some types of dipole-dipole bonds. So if it has a hydrogen bond, it'll be like NH3, right? That has a hydrogen bond because it has an NH in it, so it has to be hydrogen. But a normal bond would be something like, let's see, CHCl3, let's say. That's actually a dipole. That could form a dipole-dipole bond because of having a HCl and that would determine. So what is a van der Waals force? Okay, let's talk about van der Waals. These are actually kind of tricky. So van der Waals is a type of dipole-dipole. Basically, it's not a type of dipole-dipole officially, but you can sort of think of it that way. So let's say you have two eyes. Okay, so let's imagine two things here, how covalent bonds look. This base looks like this looks like this, and this looks like, they look like they're all together. So electrons are constantly moving. So let's just imagine these electrons constantly moving. Let's just imagine that they're constantly moving. At some point, there's a probability that let's say most of the electrons will go to this side. There's a probability that this could happen. So then this side will become negative, and this side will become like basically partially positive. At that moment, then this will bond to this. So at that moment, since this is positive, the electrons will be attracted this way. The electrons on this side will be attracted. This side will become negative, and this side will become positive. So then, that's why this is what a van der Waals force basically is. But these aren't very permanent, and these are kind of weak too. But that's basically what a van der Waals force is. It's basically like that at some point, if the electrons all move to one side, that side becomes negative, if an ion, and the other side becomes positive, and such that these electrons are attracted together and they form a bond, which is a van der Waals bond. And this is also called London dispersion. You should probably know both names just in case it comes up on a test. So just to review really quickly. Hydrogen bonds, dipole-dipole bonds, there's two types. Normal, hydrogen. Hydrogen includes a hydrogen in it. So basically a hydrogen, like an NH something, and a bond between those. And a normal bond is just basically a normal bond. And this can have either a polar molecule or an ionic molecule, because ionic molecules are polar. They're just intensely polar. So hydrogen molecules are just a type of dipole-dipole. Van der Waals are basically at some point within an I bond or something, the same thing bonded. Electrons just move over and they form a bond because the electrons get attracted away. So yeah, basically, yeah, that's it. Those are the basic IMFs. There's just the basic 3 that you actually need to know. Obviously, I'll do some examples on the strength and those things later, but just for a basic guide, normally the number 1 strength one is, the one with the strongest strength is this covalent bonds. Well, I guess these are covalent bonds are very strong. Then there's these hydrogen bonds, which are about, these hydrogen bonds are about if a covalent bond has a strength of like 100, this has a strength of about 8, and then this, and then a third comes the dipole-dipole bond. I'll just call it dipole 2 bonds just to make it quick. Dipole 2 bonds, and that'd have a even smaller strength there. That would be about 1/5. That would be the strength. And this least strong of all these are Van der Waals, because they're not very permanent. And Van der Waals is very weak. So that's just a general idea, but I'll do a later video where I talk about all these and go into more detail. But that's just basically the 3 IMFs: hydrogen, dipole-dipole, and Van der Waals forces or London dispersion. Thank you guys for watching. Please subscribe. Thank you.